Hello, everyone. Have you ever wondered how you can fairly compare two things that are just completely different? You know, data scientists actually face this exact problem all the time, and they have this really powerful tool to solve it. We call it the Great Equalizer. But before we get into the numbers, let's start with a little puzzle. How would you fairly compare the strength of an ant to an elephant? I mean, one can lift many times its own body weight, but the other one is just massive. It's tricky, right? This is a problem of scale, and believe me, it's a challenge we see everywhere, especially when we start looking at data. This whole search for balance, it's actually deeply rooted in our own history. For centuries, our rishis and scholars have understood the world through proportion. Just think about it: the precise ratios of herbs that go into Ayurveda, the perfect harmony of notes in our classical music, or even how ancient astronomers measured the vast cosmos. It was always about understanding how different things relate to each other in a balanced way. Okay, so let's see what this kind of imbalance looks like with some real numbers. We're just going to use some simple weather data, but you're about to see how these numbers can feel like they're living in completely different worlds. So here we've plotted daily temperature and air pressure on the exact same graph. But wait a minute, can you even see the temperature data? Look closely. The air pressure values are so huge that the much smaller temperature values get completely squashed flat right at the bottom. They're almost invisible. Trying to compare them like this, it's just impossible. I know, looking at data on a graph can sometimes feel a bit abstract, so let's make this crystal clear with a really simple analogy. Here we go. This picture perfectly illustrates our problem. Trying to plot our weather data on that one graph is exactly like trying to compare a tiny pencil to a giant skyscraper on the same chart. The skyscraper just dominates everything, and all the little details of the pencil, well, they just get lost. So the big question is, how do we fix this? How do we give both the pencil and the skyscraper a fair chance to tell their own story? Well, we use a beautiful technique, our great equalizer, called scaling. Now, scaling is a wonderfully simple but incredibly powerful idea. It's basically a method that takes all of our different numbers, no matter how big or how small, and it transforms them so they all fit neatly within the same range. Usually, that range is between 0 and 1. It creates a common ground, you could say, a totally level playing field for all the data. So, how does it actually work? Well, the most common way is called min-max scaling, and it's super intuitive. First, you just find the smallest number in your whole list, and you call that 0. Then, you find the largest number, and you call that 1. And finally, every other number is just placed proportionally somewhere in between. That's it. It's so simple. No complex formulas to memorize, just the basic concept. And if this is starting to sound a little familiar, it should. This is so similar to the idea of ratios that you've already learned all about in your math classes, right? Just like a ratio helps you compare different quantities by bringing them to a simpler form, scaling reduces all our data to a simpler, common form so we can finally compare them fairly. All right, now for the really cool part, the transformation. It is time to apply our great equalizer to that messy weather data we saw earlier. Let's bring some balance back to those numbers. And would you look at that? On the left, there's our original, totally unbalanced graph. But on the right, after scaling, wow, it is a whole new world. Both the temperature and the air pressure are now on the same stage, moving together between 0 and 1. You can finally see how they each change over time, and neither one is hiding the other anymore. Now, this is the really crucial point to understand. We haven't changed the fundamental story of the data at all. The temperatures still went up and down, and so did the air pressure. All we've done is bring all the characters onto the same stage, so now we can clearly see how they dance together. Okay, so let's do a quick recap of what we've learned on our journey to bring a clearer picture to our data. So, just remember these 4 key things. First, scaling gives a fair chance to all your data, big or small. Second, it brings everything to a common scale, usually between 0 and 1. Third, and this is so important, the story and the shape of your data do not change. And finally, because of all this, you can suddenly see hidden patterns you would have otherwise missed completely. So I'll just leave you with this question to think about. Looking back at our new weather graph, what new stories, what new connections could you discover after we applied the Great Equalizer? Keep this powerful idea of balance with you, because honestly, whether it's in data or in life, it almost always helps you see the world more clearly.